Hello everyone, welcome to the Bookflick YouTube channel. Now in this video we are going to understand the yield of a parse tree. What do you mean by a yield of a parse tree? So in our previous video we have discussed a parse tree, a grammar, rules of grammar, syntax of the grammar, and how can we say that a grammar is ambiguous or not. So in this case we are going to generate a parse tree that we have generated already in our previous video lectures. Now we are going to just yield that parse tree. Now by name it is suggesting that yield of a parse tree is nothing but yielding of the syntax by using the same parse tree. So let us start with this. So at first we have taken capital E as our start symbol, that is the root node of the tree, and at last we have derived the syntax id plus id star id. Now how can we say that it is id plus id star id? So in this case, we are going to yield the parse tree in order to generate the same syntax, in order to prove the same syntax. So whenever you will be given to generate, to yield a parse tree, then you will have to take a path. You will have to take a path. So how it will be taken? So in this video, we are going to understand. So first of all, we have to take this root node. Okay, so first of all, have you ever seen a tree? A tree always grows from its root. A tree always grows from its root. So this is the tree and this is the land where it is grown. Okay, so this is the root node. So a tree generally grows from its root and then to stem, then to leaves. So in this way, we are going to start from root and ending with its leaves. Leaves is nothing but the node where the tree gets ended. So we are going to understand these proper things by using the yield of a parse tree technique. So let us start with this. Okay. So first of all, we are going to start with our root node, that is capital E. So we are going to derive it. Okay, okay, okay. We are going. Okay, we have gotten capital E again. So can we say that a capital E has been derived? Capital E has been yielded? No, we cannot, because we have just reached the capital E, but we have not passed the capital E. So in order to pass capital E, we have to go further on, so that when we will reach here, then only we can say that capital E has been passed. In that case, we will be deriving the syntax of the grammar. So this capital E, we are going to again. So it should be continuous line. Okay, capital E again. Okay, we have reached ID. So can we say we have passed ID? No, because we have not passed it, we have just reached it, we have just looked at it, we have just watched it, we have just seen it. There is an id, but we have not passed it, we have not read it, we have not implemented it. Okay, so parser will this is how the parser will yield a parse string. So we are going again and again. Okay, we will have to go again. Okay, we have ultimately passed the id, because we have reached from this end to this end. That's why we have seen, we have passed the id. So we are again moving on. So we are getting capital E. So here we are getting capital E. So we can say that we have gotten the terminal id. Terminal is nothing but our leaf node of the tree. Okay, so again we are going on. Okay, we are going on and on. Okay, we have gotten this plus. So we have gotten this plus, so we will be writing this plus here. So again we start the yielding the when we have. Okay, we have reached this capital E. So can we say that this capital E has been passed? No, because this capital E we has not been reached. This capital E has not been passed, because we have just seen this capital E. We have not go from here and reached here. Then only we can say that this capital E has been passed. So let us move on. So okay, we have gotten this capital E again. So can we say that this capital E has been passed? No. So let us move on and on and on and on. So we have gotten this ID. Can we say this ID has been passed? No, we have not passed the ID. So let us move again. Okay, we have moved on. We have passed on the ID. So we can say that the ID has been seen. So we will write here this ID again because we have reached our leaf node. So let us move on further and further. So we have seen this capital E, and again this star. Okay, so this star has been passed, so we should write it here, this is star. Okay, now we will again move on. So we have seen this capital E, but in syntax we should not write the capital E capital A, that is called non-terminals. So let us move on and on. So we have gotten this ID again. So can we say that this has been passed? No. When we will reach here, we will say that this ID has been passed. So we will again write it here, ID. So in this case, we have reached E, then this E, then ultimately we have again reached and passed this root node. So this is how we are going to parse the parse tree. We are going to traverse the parse tree, or you can say that we are going to yield a parse tree. So yield of a parse tree is nothing but we have to derive the syntax, that is it is generating. Okay, so we have to generate the parse tree. Now we what we have gotten, ultimately we have gotten ID plus ID star ID. So hope you have understood it. So in this way we are going to understand this LMD2 parse tree as well. So we will start again. Okay, so let us start from this capital E. So we are going to capital E. Okay, we are going to capital E. So we have not passed. Then we are going to this capital E, we have not passed. Then we are going to this ID, we have not passed yet. But when we will reach over here, we have seen the ID in proper manner. So we can say that this ID has been passed. So we have written here ID. Now we are going to pass the plus. So we have written here plus. So now we are going to write the ID. We have passed it. So we are writing ID here. Now after this we are going to pass this star. So we have written this star over here. So now we are going to pass this ID. So we have written this ID. Is there any non-terminals? Sorry, is there any terminals or leaf node? No. So we have ultimately reached our root node. Ultimately, so we can generate the ID plus ID star ID. Now you will be noticing that we have written some associativity. We have written some associativity, that is bracket. So what does it mean? So in just like in board mass, we follow the bracket in order to solve the bracket arithmetic operators. First of all, in this case also we are going to operate this start symbol at first, then we are going to operate this plus operator at second. So in this case we are going to operate this plus symbol at first and start symbol at second. So in this case also parcel will get confused. Which one should I follow in order to generate the parse tree? So that's why this is known as ambiguous grammar. So this is nothing but the associativity. So you will be understanding that okay, I have understood the board mass rules and all. So I can generate it will be true and it will be false. No, you cannot say this will be true and this will be false. You will have to check the associativity precedence, then you can say that this is the truth and this is the false. Then only the parse tree will generate the syntax by using this parse tree. The parser will generate the syntax by using this parse tree. Okay, you cannot say this is wrong by using only the board mass rule. Okay, this has another meaning. Okay, so in that case you will have to consider the associativity and precedence of the operator. So we will be understanding the associativity and precedence of the operator. Now you will be understanding why we have written this bracket over here, because the operator symbol which will be getting the least position will be having the highest precedence. So here we have star at the least position. That's why star has gotten the higher precedence. That's why this bracket is associated with this star. Okay, and this plus is at the top of the pass tree. That's why this will be getting the lowest precedence. Now in this case, this plus is getting the least position of the pass tree. That's why this will be getting the highest precedence, and this is getting the top position of the pass tree. That's why this will be given the lowest precedence. Hope you have understood why we are getting this plus has higher precedence, why we are getting this star having the higher precedence in this case. So this is nothing but a yield of a pass tree. In this case, we have understand how a pass tree is yield. So let us understand these few lines. You can write it on your notes. Okay, since we explore a pass tree from the bottom in the left pass tree, the multiplication is done first followed by addition, which is the correct way of solving the expression, as multiplication has higher precedence than addition. But in the right pass tree, the addition is done earlier than multiplication, which is not the correct solution. So which one should the parser should follow in order to generate the same syntax? So we will be understanding how to change, how to convert the ambiguous grammar in unambiguous grammar in order to clear the confusion of the parser. So till now, this is how we have understood the yield of a pass tree. Thank you.